All right, here we go. So let's look at this part of the review. Again, isolate the function. That's how you solve every equation in the entire world. And so I isolated by adding first, right? Then I'm going to divide to isolate. So I isolate kind of the chunk. Now I'm isolating the actual function. So dividing gets rid of that. So sine of x equals half. Now again, when you're solving a trig equation that's normal, you expect two equations usually to pop out of it. All right, so let's see. Where is sine a half? And that is two places, right? Sine is a half here. Sine is a half here. Because this is square root of 3 over 2 and a half negative square root of 3 over 2 and a half. And so this is what? Pi over 6. So x or theta, if you want to call it theta, it doesn't really matter, is pi over 6. And then this would be 2, 3, 4. This would be what? 5 pi over 6. Okay, right there. And there's no pattern between them. So I can't like just combine them into one formula. If they were straight across from each other, like tangent, I could get by adding k pi instead of 2k pi and mush them. But there's no pattern like between these two is this angle, but then between these is the big angle. So we can't do that. All right, plus 2k pi, because that's our period, every coterminal angle over and over and over for both. So that is the general formulas, okay, in radians. Now, in the interval 0 to 2 pi, okay, so when k equals 0, I'm going to sub 0 in here and 0 in here. So that's when you get the pi over 6 and the 5 pi over 6. Now, notice if k is 1, I'm adding 2 pi, so it's going to be too big, okay? So I actually only get those two answers because there's no speed factor on this. I'm not speeding up my sine curve, right? It's just normal. And if it's normal, I only hit these points twice. Okay. All right. And again, some of you are like, well, Julie, you do inverse sine. I thought you said inverse sine is on the side. We or me or you, we are choosing to do inverse sine. Notice the original problem is not limited in domain. It goes forever, right? So if you choose to use inverse sine and someone doesn't force you to use it, then you're not limited in where you're at. I'll graph it after I do the next one so you can see it. All right, let's look at the next one. Oh, and by the way, on this one, if you are a big U substitution person, then you're going to solve this and you use U so you don't think when you get x equals a number, you're done. So you're still going to add your 1, still going to divide by 2, but U, when you get to U equals a half, you still have to sub back in the sine of x for the U, and then you still have to do the next step anyway, okay? All right, let's do this one. All right, so on this one, if you want to do a U sub, you can. It would be 3U squared plus 2U minus 1 equals 0. So your U is that cosine of x, okay? And what you're going to do here is you need to factor. So when you see this, you should be like, oh, it's a quadratic. It's set equals 0. I'm going to factor. So the 3 is prime, so 3 and use it, and then you need a 1 and 1 because 1's prime. You just have to figure out the positive negatives. Make your loopy. This is, I want a positive 2, so that's going to be positive negative. Now, I don't do a U sub, so because I'm okay factoring cosine of x, that does not bother me. So I'm like, okay, I need a 3 with a 1, and I don't write the 1. You could, if you want to put a 1 there, I don't care. That equals 3. 1 is prime, so I know 1 and 1. Again, I still do the loopy thing. This is a 3. This is a 1. I want the 3 to be positive and the 1 negative. So I get 3 cosine minus 1 cosine. That's my 2. Either way, you're fine. Okay. If you're going to do a U sub, you're going to set each piece equals 0. You're going to solve. So add 1. Again, isolate and inverse. Remember, we really only know how to solve linear and quadratics. And even with a quadratic, you make it linear, basically, unless you use a quadratic formula or maybe square root both sides or something like that. So I get that. But again, I should be careful. Oh, no, I circled my answer. But the U reminded me, Julie, you have more work to do. So I'm going to go back and be like, well, shoot, I need to sub back in my cosine of x. And I am not done, okay? So I just do that here. I get 3 cosine x minus 1 equals 0. Bring the 1 over by adding 1 to both sides. Again, isolate the chunk and then isolate the function. Divide by 3. I get cosine of x equals 1/3. Same thing here. Bring the 1 over, minus 1, isolate the function, and that's it. Okay, so either place we end up at the same. All right, now you, me, you, us, we are choosing to do the inverse so we can actually solve it. But notice this is cosine of x equals 1/3. If you have a cosine function and 1/3 is going to cross it infinite many times, okay, which is what this gives us. So I'm going to do inverse cosine, inverse cosine. This is me, this is you. We are not limited to the cap. We can be anywhere, okay? I have my cheapy calculator here. I'm going to switch to radians, okay? And what do I have? That is, I'm going to do inverse cosine of what, 1/3? All right, so I get 1.23 radians. Okay, now again, I expect 2 formulas from this, 2 from this. I am expecting 4 formulas, okay? 4, because usually this gives me 2, that gives me 2. Now, that doesn't mean I'm going to get 4, but I expect 4. So I'm just going to write them down. So I get 1.23 plus 2k pi. We're in radians. Now, let's think about where I'm at. All right, so 1.3 radians. A radian is if you take this radius and you bend it around the outside, right? So I bend it and you make an angle. That's, you know, about 1.23 radians. Okay, that angle, not the distance. All right, so where else does that happen? Well, let's see. This has a x and a y. They're both positive, positive. But I care about cosine being positive. So I really don't care about if y is positive. And so notice if the other place I can fold it down, right? Remember when we folded, I can reflect that down. So I'm going to fold it and come down right here. So this angle that's going negative, I'm not going to label it as a negative, but it's going down. So this one's going up, that's going down. And that's going to have that same positive x. Going to have a negative y, but again, I'm not doing sine, I don't care. All right, so if you're like, well, the problem is we don't do negative angles in there. I can't put a negative 1.23. So I need to figure out that right there. Okay, so what I'm going to do is I know that, let's see, this distance is pi, or that angle is pi, I should say. So I'm going to take pi minus 1.23 radians. All right, so I know the radians left. That angle left is what, 1.91? Well, then these are symmetric, right? This angle and this one are the same, okay? And so again, if I add that all up, it might not quite be what I want. There's 2 of those plus what? 1.23 times 2. All right, 6.28. So that's 3.14 doubled, right? That's about 2 pi, approximate, right? Rounded. So I am going to either add up these. So I'm going to add 1.23, that and that. Or if you're like, well, Julie, can't I just take 2 pi and subtract? Wouldn't that be faster? That's fine. So if you want to take 2, where's my pi key? 2 pi minus that 1.23 and get 5.05, you may. But if you're like, no, my brain doesn't like that. I want to take 1.23, add that angle, 1.91, then add that, it's kind of more that rotation idea. Gonna get the same answer. Doesn't matter. Whatever makes sense to your brain, that's what you need to do. Okay, so those are those 2. Okay, now what about this guy? Where's cosine? A -1, excuse me. So that only happens here. So notice over here it's a positive 1, and then here it would be 0 and 0. So this is an example again where I only get one answer, and that's at what? Pi, and then I have to go all the way around, 2k pi. All right, so these are my 3 general. I expected 4, didn't get it, okay? Now, interval. All right, so if k equals 0, I'm going to get all 3 of these answers. So 1.23 radians, 5.05 radians, and those are rounded, and then I get exactly pi. And if I have pi, I don't need to label it radians. All right. Now, again, this was not speeded up, okay? So when I sub in 1, notice that would be a whole nother rotation. I'm adding 2 pi. That's not going to add anything. So those are my solutions. All right, I'm going to pause, and I am going to graph both of these on decimals so you can see how you can check your answer. So let me do that quick. Let me pause, and we'll go there. Okay, so again on this, I go to the wrench. I might go, you know, -2 pi. Let's see, maybe if I can type like -2 pi and then, 2 pi whatever, step pi over 8, and then you can set this to whatever you want. You could go -2 to 2 if you want, because we just need to see where it crosses. Oh, I could put 4 maybe if it lets me. We could do -2 to 4, but do you see how you can move it anyway? Now, I want to see where these cross the x-axis. So there's one, and if you're like, Julie, it's in decimal, yeah, so then pull on this guy, and it will put it in radians. So again, if you pull it here, and then you pull it down. So notice for that first question, 5 pi over 6, those are the 2 places where the graph equaled 0. And notice I did my left and right. Okay, I'm going to hide that. My second one, let me turn these guys on, is the quadratic we did. And again, I set this as 2 separate equations or 2 separate functions because I want to see when the left equals the right. All right, so again, I might have to pull a little bit on these to get it to be in. Come on, you can do it. Let's try it this way. Oh my gosh. Well, duh, that's my radians. Sorry. A little slow tonight. That's the one that did not turn out perfect, right? And notice Desmos rounds it a little bit differently than we got, but hopefully we're okay. Did I type this right? Oh, no, I did not. So, all right, let's fix it. All right, let's try again. Let's see if this is better. Yeah, 1.23, good. All right, and then, all right, this guy is pi. Yep, that was one of our answers. And then this one wasn't perfect either. Yeah, 5.05. Okay, much better. All right, helps if you type it right. So again, I can check my answer, and that's kind of a cool graph, isn't it? I can check my answer. Now again, do you see how these other things that cross are beyond my 2 pi? So they're part, I can find all these if I want with my general formulas, but I only care about this one, and this one, the ones that occur between 0 and 2 pi inclusively. All right, let me pause that. Let's go to the next page. Okay, let's look at this page. They're giving you an angle, and a side. So that does not spell the bad word, so you don't have to worry about 2 triangles. I just drew my picture. If you draw it looking like an equilateral triangle on this, nobody cares. All right, so I did ABC. Tried to somewhat draw it well. All right, I'm going to cross multiply. So notice I have 31 times sine of 37 equals, and then I'm going to get the sine of 40 times the b. So that's what you divide by. So a lot of people just remember multiply these and divide by kind of the odd man out because you're going to end up dividing by that sine of 40. And so some people don't write it, which is fine. So I'm back on degrees. So I'm going to take my 31 times the sine of 37. So sine of 37 and that angle there. And then I'm going to divide by the thing by the b. So divide by sine of, what is that, 40? Okay, equals. So I get, and I'm solving for side b. So b is about 29.0. Okay, all right, so that's side b. So I could put that in here, 29.0, and over here, 29.0 inches. Now, that is a rounded number, so even though I got it, unless you use all of it, if you want to use all of it, great. I'm not going to use the rounded number to get A, okay? So I'm going to cross multiply all the way across here. So I'm going to take the 2 numbers that are here. So I'm going to take 31 times sine of 103, and that's going to equal the cross product, which is A times sine of 40 degrees. And then you end up solving this equation, so you end up dividing both sides by that sine of 40. So again, a lot of students just remember that if you have the 2 numbers, you multiply and then divide by the one by the variable. So I'm going to take, I'll do sine of 103 first. Make sure you close that because that's the degree, times the 31 separate. If you don't have a good calculator, I would take the 31 first times that. Enter, and then divide by what? Sine of 40. And what do I get? Okay, so it looks like what am I solving for here? A is about 47.0. All right, so A is approximately 47.0 inches. All right, I know all my angles on my sides. And again, I didn't show this, but the way I got the missing angle was by subtracting from 180.